Alright, what's up guys? Let's do problem of the day. Alright, 15 minutes on the clock. We have two special characters. The first character can be represented by 1 bit 0. The second character can be represented by 2 bits 1 0 or 1 1. Given a binary array bits that ends with 0, return true if the last character must be a 1-bit character. The last bit must be a 1-bit character. Well, we have 1 0 0, right? So 1 0. Okay, true if it must be a 1-bit character. Okay, so 1 0 has to correspond to either 1 0 or 1 1. And obviously it corresponds to 1 0. And so this last bit is going to be a 0. If we look here, we can do wait a sec. Oh no, yeah, we have 1 1 and 1 0. Makes sense. So we never have to have a single 0 or we don't have to have a single 0 for the last bit. Is the bits valid? I guess it would always be valid as long as it ends with 0, and that's guaranteed that it ends with 0. So I think this will always be valid. How can we test this? Let's do another example. Let's make it a little longer. Let's do like, yeah, sure. Hold on, sorry. So how would we do this? So if we see a 0 here, we know there's nothing preceding it, so we know we have to take the 0 by itself. And now we see a 1, so we have to take the next two characters. So we have to take this 1 1. Then we see a 1, which means we have to take this 1 0. Then we see a 0, we have to take the 0. Then we see another 0, we have to take this 0 by itself. Then we see a 1, so we have to take the next character as well. And then we get here. So it seems like we can just go from left to right and then see which character we're on. If it's a 0, we have to take it by itself because we're going left to right, which means every character before us has already been processed. So here we have to take the 0 by itself, and now we end up at the 1. And for 1 to be valid, it has to be either 1 0 or 1 1. So we have to take the next character, and we'll get 1 1, which will bring our current index here. And then we'll see a 1 again, so it has to take the next character as well. So take 1 0. Now we have to end up here, and then since there's no like 0 1, we have to take 0 by itself, and then okay, so it's yeah. I thought we would have multiple options, and there were like different choices we can make, but it seems like there's only one option. So we can do, well actually let's do a while loop here. So okay, so if bits at I is a 0, then I plus equals 1, else I plus equals 2. And so if this is the case, I just want to know like where we're going to end at when this loop terminates. Oh, you know what? This should be length of bits -1. We don't want to process this last character. And if this last character, well, if our index ends up landing on the last element in bits, we know it's a 0 based on the description here, and that means we can return true. So if I is the length of bits -1, we'll return true, and actually we can just return this statement. What's happening here? Oh, okay. Whoops. All right, cool. Pretty simple, pretty simple. Yeah, essentially what I did, I think. No, it's not. Whatever, this was simple. All right, thank you for watching.